First of all, IBF plus initial basic feasible solution. Put x1 is equal to 0, x2 is equal to 0, then we get s1 is equal to minus 3, s2 equal to 0. So for every linear LPP, for our better understanding, if we give minimum z, we can convert into maximum z by multiplying minus 1 on both sides. Similarly, we also convert greater than or equal to symbol into less than or equal to symbol for dual simplex method. If it's given this like. So let's start. Initial simplex table. Simply I call IST. When it is only two slack variables because we have two subject to the constraints. X1 minus 6 minus 1 0 0. For dual simplex, we find Zj minus Cj greater than or equal to 0. Here Zj value 0 minus 6 minus of minus 6 plus 6 minus of minus 1 plus 1 0 0. So what is the difference between the simplex method and the dual simplex method? For simplex method we find first entering vector, but in dual simplex method we can find living. So how do we find living? We choose the which is the minimum value, 0 or minus 3, minus 3. So which is the key row. S1 is the living vector. For entering vector, for dual simplex method, we have the formula maximum Zj minus Cj by Xjk, where Xjk is less than or less than 0, not less than or. No, just here maximum Zj value 6, corresponding value minus 2, comma minus 3 minus 1, which is maximum, minus 1 is the maximum. So which is x2 is the entering vector. Next, iteration table 1, Cj, Cb, Xb, X1, X2. So S1 is a living vector, X2 is the entering vector. Here white X2 as it is S2. X2 cost coefficient -1, 0. Where is a pivot element -1. We have to convert into 1. So we multiply with -1 for all the row. -2 into -1 plus 2, -3 into -1, 3, -1, 0. Here use this short trick. If suppose x2, x21 remaining 0, s2, s21 remaining 0, find the new values. 0, which is the key row, minus of 1 into new variable 3, here -3, -1 of 1 into 2, -1, -2, -3, 0 minus of 1 into -1 plus 1, ZJ, -1 into 2, -2 plus 0 into -3, 0. So we have -2, -1 plus 1, 0. ZJ minus Vj greater than or equal to 0. ZJ -2 minus of -6 plus 6, -2 plus 6, 4, -1 plus 1, 0, 1, 0. If Zj minus Cj all are greater than less than or equal to 0, it is equal to 0, it is greater than 0, it is equal to 0. We have to stop the process, but we have the basic variable as -3. So we, for dual simplex, we have to, there is no place for minus negative values. So we have to calculate for positive values. So we have to find next iteration too. So for dual simplex, first of all we find key row, which is the most negative value -3. It is a key row. S2 is the living vector. We are finding entering vector maximum. So we are only negative value xk, negative value is 1. So x1 is the entering vector. Here x1 is the entering vector, cost coefficient -6, -1. So here the key row. It is a -3 is a pivot element. We convert into 1 by dividing -3. 1 -3 -3 1, 0, 1 by 3. Sorry, -1 by 3, -1 by 3. We use short trick, x2, x2 1 remaining 0, x1 1 remaining 0. We have to find 3 new values. 3 minus corresponding key element. 2 into corresponding key value 1. 3 minus 2 equal to 1. This one. Minus 1 of minus 2 into minus 1 by 3. Minus 1 plus 2 by 3. So we have minus 1 by 3. 0 minus of 2 into minus 1 by 3 plus 2 by 3. To find ZJ value minus 6 minus 1 here minus 1 into minus 1 by 3 1 by 3 plus minus 6 into minus 1 by 3 2 1 by 3 plus 2 3 2 ja 6 7 by 3 here minus 2 by 3 minus 6 into minus 1 by 3 plus 2 6 minus 2 plus 6 by 3 4 by 3. Find Zj minus c is greater than or equal to 0. Zj minus 6 of minus 6 0 minus 1 of minus 1 0 7 by 3 4 by 3. We have also find Cj minus Zj is less than or equal to 0. Cj 0 0 minus 7 by 3 minus 4 by 3. So here all for Zj minus Cj all are greater than or equal to 0. It is also all the positive variables. So we have to got answer x1 is equal to 1 x2 is equal to 1 are the feasible solutions. Optimal feasible solutions for minimum z 6x1 plus x2 6 into 1 plus 1 7 minimum z is equal to 7. So this way we have to find optimum solutions for dual simplex method.